Okay, sorry. So South Carolina won 2.2 or 1.6 more games, okay, than expected. Based on the, okay, more than expected based on 30.1 points per game. Okay. All right, so that's your residual. What you decide. You can pick 2 or 1.6. The book uses 1.6, but I don't understand how you can have 1.6 of a win. Okay, now the next one. It says, what does it say for part B? Is a linear model appropriate for this data? Explain. Yes, it very much is appropriate for the data because there are overall no patterns inside your residual plot. So if there had been patterns like, this upside down looking parabola thing or this curve happening over here, then we definitely wouldn't be using a model. Okay, so that's pretty much my explanation. So I would say yes, because there are no obvious patterns in the residual plot. A linear model is appropriate. Okay. Okay, next. Interpret the value of S and interpret the value of R squared. So those are the two new things that you did in this one. Okay. So your value for S was 1.24, which is okay. Okay. So we're going to say, okay, when we use, okay, all right, when we use the least squares regression line, we will typically have a prediction error of 1.24, and that's it. Or 1.24 wins, I should say, because we're actually talking about the wins in this case. So when we use the least squares regression line, we will typically have a prediction error of about 1.24 wins. All right. Every time we calculate the residual, we can figure out, okay, well, typically we were off by 1.24 wins. Okay. Interpret the value of R squared, and this is the one that always throws me for a loop, like every single time. Okay. Now, let's see how we're going to do this. 88, because this is about 88%. Okay. So interpret the value of R squared. Okay, about 88% of the variation. I think that's a good word. Okay, so about 88% of their variation can be variation between points and wins, can be associated. I would say associated. Can be accounted for by the linear model. Okay, it's like a weird. I usually say 88% of their variation can be between points and wins can be accounted for. Well, can be attributed to the linear model. So you're about I know this is bad, but I usually think of it like, okay, we're about 88% good on using our linear model to graph our data, but I know that's the totally wrong way to think about it. The good news is we're about 88% of the variation. So you want a high R squared. You don't want a low R squared. Okay. All right. We're going to get more of these during class time, so I'm not too worried about it right now, especially the R squared value. Okay. So that was residual plots. Look at the next video because we're going to do regression outputs and then some funky stuff in this one, let me tell you. Okay.